Anybody? Can you
Lack
guess?
of coordination.
Exactly. So it's very likely the owner, which means this university, outsource, the light fixture installation to one company and the light fixture to another company. Very likely is they build the sprinkler first and the light fixture the second. So they just don't care. This is the drawing I received. This is the design I have. I just do whatever it asks me to do. I don't care how it would look at the final function. So who will be responsible for this? Unfortunately, it is very difficult to say who will be responsible. The owners and the general contractors really have to take care of themselves. And that's the importance of collage detection. I think you guys know how it runs. It's perfect time for us to review the concept of collage detection now. So collage detection or constructability review is the number one popular function of BIM today. And actually, there are more general contractors, construction companies are using BIM than the design companies. I think the number one driver is the ability to run collage detection. Okay, so constructability is a project management technique that reviews construction logic from beginning to end during the pre-con phase to identify roadblocks, constraints, and potential issues. And we use BIM. Usually, it's running on the spatial conflicts, but also BIM can run, this kind of conflict. So this one, the sprinkler is not touching the light fixture, but we know there's some rule associated with the sprinkler, like there shouldn't be any obstacle, let's say 5 feet below that. So if we also import that rule inside the BIM can also run something called a heuristics-based collage detection or rule-based collage detection. It's a very hot research topic nowadays. It's in addition to the spatial conflict uh, uh, constructability review. So I found this one. Um, this is also part of the constructability review. It's a interesting picture I found online. Do you guys know what's going on here? So in the drawing, for the paper-based drawing, we usually use this cloud type of shape to mark up things, the call out, right? So basically use this one as our paper-based collage detection running, but some construction guy just build it. They draw a hole of exactly the same shape on the floor. It's just interesting. So talking about the collage detection, and now it's important to introduce this concept of level of development to you. So what is level of development? Let me show you this quick video first. Let me make sure you guys can hear the sound.
Welcome. My name is Rob Miller. Today we're going to take an introductory look at level of development, or LOD. The term LOD has been around since the 1970s and described decreasing the level of detail of a 3D object rendered by a computer as it moves away from the user. Simply put, the closer an object was to the user, the more detail was shown. This makes sense for a number of reasons, the most important being the computational power of computers in the 1970s compared to today. Only in the last decade has building information modeling, or BIM, become a reality, despite being first mentioned around 1990. According to the U.S. National Building Information Model Standard Project Committee, building information modeling is a digital representation of physical and functional characteristics of a facility. A BIM is a shared knowledge resource for information about a facility, forming a reliable basis for decisions during its life cycle, defined as existing from earliest conception to demolition. In 2011, the BIM Forum put together a group of professionals to review model element geometry for quantity takeoff, 3D coordination, and 3D control and planning. And in August of 2013, the 2013 Level of Development Specification was published. As stated in the introduction, the Level of Development Specification is a reference that enables practitioners in the AEC industry to specify and articulate, with a high level of clarity, the content and reliability of building information models at various stages in the design and construction process. Now, simply put, this specification is a common language by which architects, engineers, contractors, and owners can convey and understand the detail level and reliability of a model. There are 6 fundamental levels of development: LOD 100, 200, 300, 350, 400, and 500, each one increasing in the amount of graphical and non-graphical detail included. Let's take a look at an example of structural steel framing to see what the difference in LOD looks like. At LOD 200, the shape of the tapered steel columns and beams are within a 1-inch tolerance, while the slope of any inclined elements are modeled to plus or minus 5 degrees. Deflection and bucklings of the beams and penetrations are not included. At LOD 300, the shape of the tapered columns and beams are within a 1/2-inch tolerance, while the slope of any inclined elements are modeled to plus or minus 2 degrees. Beam deflection and column buckling larger than 2 inches is included, but penetrations are still excluded. At LOD 400, the shape of the tapered columns and beams are within a 1/4-inch tolerance. Trusses are now modeled, beam deflection and column bucklings larger than 1 inch are included, and penetrations are now included as well. Also, connection plates and members between primary and secondary steel elements are shown. For a complete explanation of level of development and examples of numerous building elements, head over to the BIM Forum website and download the complete 2013 Level of Development Specification for free. Thank you for taking the time to watch this video. And remember, you can follow us on LinkedIn.
All right, so this is LOD, and like this video showed, it's actually borrowed from the concept level of detail. Level of detail is a popular concept in gaming industry. If you ever play video games, if you don't have a strong computer, you can always lower the level of detail so your computer can render the game more smoothly. In construction, in BIM world, LOD is called the level of development. Please keep in mind, next time when you talk about LOD to others, don't say it's level of detail. It is extremely difficult. It's different. It's called the level of development. Why? Because the level of detail usually only refers to the geometry, the appearance, the graphical details. In gaming industry, we use little triangles to show the surface of an object. So the more triangles you are using, which we call polygons, the more details you can simulate, which makes sense, right? So the more triangles, the more changes on the surface you can render. But the level of development will include graphical as well as non-graphical information. A higher level of development usually means more level of details plus more information. Let me say that again. A higher level of development usually means more graphical details plus more information, because adding more information usually means more effort. So we call this level of development. So actually, when we say level development, there are actually several keywords. Let me tap it here. It shows that more details, but also more higher accuracy, precision, and also information. So these are the 4 things that you have to keep in mind to differentiate, between this level of development and level of detail. Detail is only one thing of this one, but a higher level also means it's more accurate. Like what the video introduced, we have some tolerance for a model. All models are wrong. No model is perfect. So they are always adding some deviation between your model and the real structure. The accuracy requirement will increase higher and higher while you have a higher LOD. So that's a basic, a differentiator between level of development and level of detail. And of course, more information. So for example, for a low level of development model, you probably only got limited information such as the material type. But for a higher level, you probably also got the installation rate, the PSI for it, or even the phone number of the supplier. So you actually add potentially higher, more information inside it. And like I said, there are 6 levels of LOD: 100, 200, 300, 400, 500, and a unique thing called 350. Let me give you some example. The LOD 100 usually is useless. It only shows the overall geometry, the shape of something. So it shows that LOD 100 is just a symbol or generic representation. Information related to that to the model can hardly be derived. Such like this column, LOD 100 can only show you the rough shape of the column. Then 200, you are adding further information. So the model elements is graphically represented within the model as generic system, object, and assembly with approximate quantities, size, shape, location, and orientation. But at this point of time, only limited non-graphical information is attached. So for example, for this I-beam, for a IoT 200 model, you probably can see the shape of this I-beam, the I shape of that. So IoT 300 is here. So for IoT 300, the model elements is graphically represented within the shape of the model as a specific system object or assembly in terms of quantity, size, shape, location, and orientation, and more information attached. For example, for this case, the color of that and the very detailed connection between the flange and this plate is also showing up. So let's skip LOD 350 for now, and let's see 340. 400 LOD is something called um, uh, the best quality LOD before construction. It's the master design. So imagine you have the most precise and accurate BIM model before the construction to show even every single bolt, every single screw, every single hole on the wall. It's the most wonderful BIM model before the construction. That's called LOD 400. Then what is LOD 500? It's called as-built model. We always know, the model, the product you build will be always different from the original master design. So if you also build a perfect model to show the final project, it's called LOD 500. So what is LOD 350? So here's the thing. In 2013, I was lucky. I got invited to attend the meeting of AGC local chapter in San Antonio. And the entire meeting, originally people were talking about building information modeling, different aspects of that. But soon somebody mentioned this LOD 350. At that time, nobody knew what that meant. And that person was talking about this LOD 350 and the potential of that. And you know what? That guy was right. LOD 350 is actually the golden standard today, golden LOD standard. So what is LOD 350? Yes, it is more accurate and provides more information than LOD 300, but not as accurate and more detail driven, like LOD 400. So you can tell from here, this is from 300 to 350 and 350 to 400, how much detail is being added. So here's the thing: why 350 is so popular, so interesting. Uh, the biggest difference, the definition for 350 is 300 plus interface. So what is interface? Interface means different systems, different components, different materials when they come together. Where these different materials, systems come together, that's called interface. For example, if you are building a pipeline, it's PVC pipeline, and it's connecting somehow going through the wall is concrete, and this PVC pipeline is PVC. That connection point is interaction, interface, okay? Or if you are building this light fixture with one company, another fire sprinkler is with another company, even though they are not coming together, but that general space is called a construction interface. So can anybody tell me why LOD 350 is critical, it's important for construction company? That's a question. Anybody?
Because it has more details.
It has more details, so then why wouldn't we go to LOD 400? So there's a rule of thumb, guys. First, you have to keep in mind, the higher LOD you're developing, the more cost you will occur. So a rule of thumb, every time when you move 100 level, from 200 to 300, from 300 to 400, you are doubling your cost for model development. So nowadays, the construction companies and the design companies in the US, I'm not saying that every company, but I have to say probably half of them outsource their BIM work to some overseas company. Most companies are from India. They basically just send the drawings, the design specifications to the Indian company, the outsource company, and usually, they charge you like from 50K to 100K to develop let's say like a school building for the model. But every time when you say, hey, my requirement is moved from 200 to 300, they probably will have to double the price as well as the time. Because you see, it's understandable, right? It's more details to be included. So here's the thing. Why wouldn't construction companies stay with LOD 300, which has been a common practice? Of course, 200 is probably not enough. You can see from here, right? And 400 is probably too much for construction company, right? And before 350, a lot of construction companies just stay with the 300 until somebody proposed this concept of 350. You can tell from the number, 200, 300, 400, 500. Why 350? Because it was proposed later. So why this is important from this definition? Why 350 is so important for construction company and become so popular, become a golden standard for the BIM world today? Because the source of construction issues is the construction interface. Now, guys, understand? Remember, we talk about why MEP will have all the issues. It's all because they are designed by different parties and they never talk together. That's construction interface. So for concrete and for the pipe, different materials, different system, when they come together, so this part is sorry. So this part is what? Interface, and this part interface. Let me see what else, that here interface. So now we can imagine very likely, this part is done by one company and this part is done by another company. So the likelihood that you will have issues like design issues, coordination issues for those interface is much higher than other places. Make sense? That's why 350 is the most proper level for construction company to review potential clashes. Make sense now? So if you want to run a good, clash detection, you want to make sure your model is a 360 LOD model. The model I shared with you guys, the green facility in Vancouver, Canada, that is a LOD 350 model. I hope it makes sense to you guys now, especially when you see this real case. This actually shows the interface. So that's where the problem is. If your model doesn't have enough detail to show the details of how two things come together, you wouldn't be able to discover that clash. But if you go too much and go find a IOD 400 model, you have to pay more, much more to develop this model. Make sense? Okay, so depending on that, like the video mentioned, we do have this LOD specifications. It's also standard that a lot of contracts are using. So the contracts, especially for California, their public owners usually require you to submit a BIM model today, and they usually specify you have to submit a LOD 350 model, in the contract. And so if you just Google BIM LOD, if you lead you to this one, and you can see all the specifications from 2013 to 2019. So let's go there and show you how it looks like. It basically gives you definition of different LOD and the examples for different components in your building. So let's say, let's go find the slab on grade. And then, by the way, this is how they organize everything, something called a uniformat and omni class. Kaylin, you mentioned that you just did the test. Can you tell us what is the uniformat?
Oh, I didn't know about uniformat. It was just a CS.
CS master format, right? Yeah, so like master format, uniformat is yet another work breakdown structure used by companies, okay? So master format is more popular for general contractors because it's organized as materials, right? So this division 3 is concrete, division 4 is masonry. So for estimators, they love that master format. For uniformat, it's more popular for design company because it's based on system. So they can, it starts with a letter A, B, C, D, followed by 6 digits. It just shows, this is a foundation, this is wall, this is window. It's nothing but just yet another work breakdown structure to organize things, okay? Omni format, similarly, is the third, work breakdown structure being used by a certain company. The most popular work breakdown structure is master format, uniformat is second, omni class is the third, generally speaking. Okay, so let's go find this slab on grade. So this structural slab on grade. So basically this standard shows that what that means, and then tells you 100, 200, because 100 and 200, they are oversimplified, and usually people don't use them. So this specification just gave a general definition to LOD 100 or LOD 200 for most of the components. So they just tell you to refer to them. And then this is 300, for this structural slab on grade. If you are confident to say, hey, my model is the 300 model, then you should include overall size, thickness, and the geometry of the slab on grade. The major openings, such as the large mechanical elements modeled to nominal dimensions, should be shown. Slab depressions should be shown there. The edge turn down should be there. And also all slope surfaces, including the model elements, with exception of elements affected by manufacturer's selection, which are not known at this LOD, should be included. Okay, so this is 300. Then what is the 350? Now you can see this is what I'm talking about. Once again, guys, this is interface. Makes sense because we are talking about potential concrete and rebar. So 350 is all penetrations modeled to rough openings, dimensions, the pour joints, the control joints, the expansion joints. Once again, why these joints, guys? You see the detail that are giving for this 350 here is more than there. It's all because this is talking about one system coming together with another system. So the chance that we will have issues here is much higher. Then we want to give more details. So that's called construction interface. And you see rebars and any embedded elements should be modeled. Once again, different materials, that's construction interface. Okay, so that's LOD 350. And also we have 304 LOD 400, fully modeled rebar, actual slab dimensions, post-tension components, all joints, waterproofing, that means the surface of that, and also finish, okay? So you see how these specifications define the definitions, and give you the visuals. Let's take another example. Hopefully we can find a column. Column foundation. Okay, this is a good example. So this is a column foundation, the deep foundation, okay? And once again, the 100 and 200, please refer to the overall definition, which is given here. 100 is assumptions for foundation are included in other modeled elements. For example, I have this slide and I do need to show this column foundation for the slide. And as far as I'm showing that relative relationship and relative shape, I'm good. That's LOD 100. LOD 200 means the approximate size and the shape of the foundation element, and the structural building grades for local project coordinate system are defined, which means the location must be correct. So that's 200. And if we go deeper into this 300, that means, assumed bearing depths per geotechnical report, here the depths, with design penetration geometry modeled. So it's which level of soil it goes into, the dimension of that should be modeled. Top of pier should be modeled. Size of the pier should be modeled. Area of bearing influence modeled or accommodated by model checking software should be modeled. Okay, that's 300. 350, the actual top piers and the expected bottom piers modeled, and also foundation door location and anchor rods if applicable. What that mean? It also means interface. So I think I said this word like 20 times already, but this is extremely important. It's the interface. Then 400, you can see we just jump to a very detailed view of the rebars to 400. It's the depth of bearing stratum, penetration into the bearing stratum, locations of a lap splice, rebar, including the hooks and the lap splice. You see the details, the overlaps, the spacing of the rebars, the doors, the pier slide and pier views, and the bolster for bottom clear cover. That's 400. 500 in terms of this detail is the same, but the 500 reflects the as-built, not the master design. So if you're interested, you can go definitely go, Google this BIM LOD and check the detail. It's an overwhelming document to give you pretty much very clear the design of pretty much everything, in your building and the definition of that. Now here's a quick question for the class again. Why we need such a very detailed specification to define different level of development?
For the contracts?
Exactly. Nowadays, owners require you to submit, BIM documents with certain LOD, but we also know if you move higher in LOD, you are spending more. So this becomes a legal issue. And because every time when it becomes a legal issue, we need very clear definition with no fuzzy boundary. Otherwise, there will be a problem, right? So that's why they keep expanding this specification. As you can see, before the latest one is 2019. Before that, we only got one document, but for 2019, we started to have two parts. The documents are twice as long as the previous specifications. It's just providing more and more information. Unfortunately, if you decide to work in this BIM world, like to find a job as a BIM coordinator or BIM modeler, you have to keep these things in mind. These things will become your intuition and will become a part of you. So when you model the things, okay, so I'm towards this 350 LOD. I know I need to keep in mind this is the detail, this is the information I should include in my model. Okay, so hopefully that covers enough for you guys to understand LOD. Since this is so important concept, don't say LOD is level of details. This is the level of development. And the most important one is 350. Definition is very simple. It's 300 plus interface. Okay. So with that said, when we run clash detection, we actually need to run this on at least a 350 model. Okay. All right. So that's the most popular application of BIM for pre-con is the clash detection or constructability review. The second most popular BIM for pre-con is the 4D simulation, and this is the next in Beijing. The 2008 Olympic game. They actually built this one. It looks like nothing from far away, but if you go closer, this is the detail how it looks like. The complexity of this building is out of imagination. This is actually one of the earliest projects that used 4D beam right in 2005, 2006. They already used the 4D beam to coordinate the building of this one. It's probably one of the earliest project using 4D. Let me play a quick video for you guys. Sorry for the resolution. This is a pretty old video.
It's beautiful. It's good. Good architecture. I like it. It's the bird's nest. It's called the bird's nest, and I think it fits. The right name for it.
As the main venue of the 2008 Beijing Olympic Games, the National Stadium has been the focus of international attention ever since construction began in 2003, and it took just 3 years to complete. In March 2002, China launched an international tender for designs for its new national stadium. Eventually, a specialist appraisal committee chose the bird's nest design, submitted jointly by the architects Herzog and partner, ARUP Engineering Consultants, and the China Architecture Design and Research Group.
In the past, most of the stadiums were built only by engineers to make it purely functional, technical building. And we believe that the Olympic Stadium should be more architectural, cultural, public, social.
Thomas Herzog is a famous Swedish architect. With his partner Pierre de Meuron, he won the 2001 Pritzker Award, the most prestigious prize for architects in the world, and the bird's nest design was their latest collaboration.
So it involves other criteria, also aesthetic criteria. For that reason, it needs to have a specific shape, and we're very much inspired by, you called it bird's nest. You could also think of a vase, of an object that is done to collect people, to be a collective form. That was the reason for this very special shape.
The stadium's novel design presented its builders with numerous challenges. Never before had anyone attempted such a complex structure as an imitation of a bird's nest.
Yeah, actually unfortunately this video didn't show the detail of that 4D simulation, and I tried to find, the videos for that, I couldn't find it. So 4D simulation is, before the first shower of the dirt moves, the project managers and stakeholders, they must, coordinate the efforts, running this type conflict analysis. Usually the audience of 4D simulation doesn't only include the general contractor, but also the owner and the subcontractors. That's extremely important, especially if we want to resolve the potential time conflicts, schedule conflicts. You definitely want to invite your subcontractors together to run the 4D simulation. And I have a couple of successful stories running 4D simulation. This is a new Jahar building, a hospital building in Saudi Arabic, and it's a 14-story building. The total area size is more than 5 million square footage that can host more than 1,900 beds. And this project, they also use this 4D simulation to coordinate their efforts. And I did find this high-level 4D simulation is probably IoT 200, and let's see how it looks like. Let me fast forward this a little bit. As you can see, it shows, you know, the concrete pads, and also even includes the footing for the main columns. And this follows the schedule exactly, as you guys can tell from your own 4D simulation experience. You have that schedule. This one just visualizing the schedule, and also shows the direction of the walls, the roofs, the floors, and more partitioning walls, supporting structure, columns, and from different angles, moving camera. You guys can definitely do some something similar with Navisworks. You guys can also see the temporary supports. And pavement and landscaping later. And as you can see from here, this is done by this Bexel consulting company. And like I said, a lot of times, you know, the owners and the general contractors, they outsource their BIM services to these consulting companies. And for this 4D simulation, it serves two functions. One is the bidding. You know, as the general contractor, you want to impress the owner and to show the logic of your bid. So 4D simulation is definitely the selling tool. And also the second function is a coordination tool. Like if you invite all the subcontractors could be involved in this project, like the curtain wall, that's definitely one subcontractor. Foundation, that's another one. Mechanical equipment, that's another one. And of course, the pavement and landscape, that's different company. So if you can invite all your potential collaborators to the same table and run the simulation, there's a bigger chance that they will discover the issues and problems before the start of the project. So that's the one successful story. And this is another one. It's the Shard of Glass in London. It's a 95-story building. The head is more than 10,000 feet tallest building in Europe building. The planning started in 1998, and after 4 years, 5 years, it finally got approved. And after another 4 years, finally got funded, and another 2 years, they finally got started. And the construction only took about 3 years. Now you guys can see, this is an example showing how the life cycle of project look like. The construction part is only 3 years, but the planning of that actually takes much longer than that. So the challenge of this project is the installation of all the glasses. So this project used more than 11,000 panels of glasses. The total area size is more than 600,000 square foot, and they had to use 4 cranes, climbing cranes, to build this building. So the 4D simulation in this project was extremely important for them to coordinate the movement of the 4 cranes, because crane could have a lot of spatial conflicts, and there are actually people researching crane deployment and the installation as a research area. So let me show you this the 4D simulation of this model. So of course, it also shows, the construction part, but that's not the focus of this simulation. As you can see, start to simulate the, the cranes and how the location of them, how they should move as the building is going on. And then it starts to show the climb crane that is going as the building build up. Okay, so you get a point, right? So the 4D simulation can focus on different things, and for this particular project, it's the crane use. I found this project to be very interesting. It's the Content Tower in Guangzhou, China. This is probably the best 4D simulation model I have ever found to show the level of details and how informative it is in terms of getting not only the main components, main operations, but also the very detailed construction activities, how that should be done. Unfortunately, I couldn't find the one with English. I found this one with Chinese, but it has the English subtitle, so I really want to play this one. So a quick data about this tower. It's the height is almost 2,000 feet, tallest in the world in 2010. Planning started in 2004, construction began in 2005 and finished in 2009. The total area size is almost 2 million square foot. It used 5 cranes, including 1 climbing crane. And you will see how informative the 4D simulation can be.
矗立于广
You guys can see the English subtitle, right?
Yeah.
州市新中轴线上的广州新电视塔，将会是广州市标志性建筑。新电视塔总高度达610米，是由一座高达454米的主塔和一个高156米的天线桅杆所构成。本短片所显示的施工方案，目的在于证明塔体施工的可行性和更了解塔体施工的 估计内筒的典型施工周期约为1星期。在施工初期，
Now you can
建议
see
采
actually the
用5台
moving of
塔
the
吊
tower
进
cranes
行
and the
主塔
trucks
施工，
and how they
其
move
中
this
1台塔吊可沿
columns.
核心筒外侧爬升，而其余4台塔吊则设置在外筒外围。钢结构组件会在加工厂制作，然后利用驳船经珠江或用货车从陆路运至工地。组件会先运到工地的临时工作间进行焊接、拼装、修补、检查等工作，以及在吊装前在地面进行组件预拼装。钢结构的施工顺序为：1. 安装外筒钢管混凝土柱的柱脚； 2. 按顺序将竹环吊装柱及环梁组件当柱及环梁吊装后，再吊装斜撑。3. 安装楼面主次梁。4. 在没有功能区的范围安装临时支撑。5. 继续上部钢结构安装，拆除下部的临时支撑体系及在上部重用。钢结构组件基本分为柱子段，包括一段长度为8至12米柱子，以及斜撑和环的短支接头。斜撑8至12米长，环3至6米长。柱子段的最大重量需控制在约25至30吨，以配合塔吊能力。环的安装的
So this
施工
part
平台
shows
系
that
统
how they actually connect two column structure and also bolt them up and put the concrete. Very detailed for the simulation.
需要设有高、中和低3个平台。高平台主要给人员进行低位的构建焊接工作。中层和低平台除了给人员进行高位焊接工作外，亦用于拆除下部以焊接组离太大，即考虑到施工循环工作已进入成熟阶段，因此可以较近，斜撑与柱之间的夹角较小，可考虑斜撑、环梁与柱焊接后统一吊装。在塔体上部结构施工时，其分拆形式基本同塔体下部。混凝土浇灌方法建议混凝土先从地面泵送至所需高度，然后采用象鼻泵机把混凝土从内筒的管道直接泵送到柱子内。这是由于外筒每根柱与内筒的距离沿高度甚至在同一标高亦不一样。塔体施工继续，每当完成一个楼层的施工后，下部的临时支撑便可拆除。拆除的临时支撑构件经过修正长度后，便可重复使用。
So this part of video talks about
Tang-Tati.
how they remove the temporary supports. All right, this is it. Like I said, this is probably the best quality 4D simulation I have ever seen, and um, some of the details can actually get the front line workers at how to do their welding, concrete pouring. So it's an amazing piece of work. And the most surprising thing is, I don't know how much it cost them to build this 4D simulation model, but I do know a similar project only costed, it's a company in China, only costed them about 500,000 yuan, which is only about 70K US dollars. So think about for 70K dollars, for this, uh, the project of this size and the potential benefits from that, I think this you definitely have really good return on investment, and that's the beauty of 4D simulation. So we have seen, like some, building project and vertical projects and the potential success stories for the simulation for them. 4D simulation can also be used for horizontal projects. Like this is a tunnel project in Austria. The total length is almost 5 miles. So it's connecting Slovenia and Austria uh, to be finished in 2025. It would take them good 10 years to do it. And this is the same consulting company, Bexo. They actually did this 4D simulation model for this project to coordinate the horizontal work. So for tunnel, of course, you want to simulate the earth moving because earth moving is the important part. This is concrete. Just a quick question. Do you guys know what are these like rods or rebars for? Nobody? These rebars actually go into the rocks, right? So these are the anchors go into the rocks to reinforce the entire structure. The dewater system and the pipelines and utility lines.
Professor,
Yes.
what LOD would this be? Roughly,
That's
I
a
know.
good question. I think should be, it depends. And for the entire project, it looks like just LOD 200, especially for the concrete structures, you can tell, right? But for the utility lines, I think that's probably LOD 350, especially it shows, for certain parts. Let me see. Yeah, like for example, for this part, you definitely see the interface, right? Like how this utility pipelines coming, interacting with other parts of the story. So yeah, that's 350. But for certain concrete, like the concrete pad, that's definitely just 200. There's nothing detailed about that. So I guess for this project, they just highlight, the areas that they believe to be important. And that's also a good example showing that you probably don't need the same LOD for all parts of the project. Depending on your need, you can definitely have different designs of LOD. Okay?
Okay,
Yeah.
thank you.
All right, so that's another successful story, and so talking about the last pre-con, popular pre-con use of BIM is the 5D BIM, BIM for estimating. We will be having a guest speaker from Bartley Cork. It's I think the top 50 builder, and the guy is working for the VDC department in Bartley Cork, the headquarters. And so he'll be introducing their practice of using 5D. So I'm going to skip this part. So he will give the guest lecture in about 2 weeks. Let me see what else we need to cover regarding. Um, yeah, there's one more thing I want to show. Here it is. So this is actually a map that I got from Bartley Cork, their current practice in terms of how BIM can benefit their pre-con and pretty much the entire process, not just pre-con. So from conceptual design to schematic design to DD to CD to construction to facility management, Bartley Cork is using BIM everywhere and anytime, okay? So they use SketchUp and Revit for the conceptual design, and of course Revit for the entire design and the construction document generation. For structural design, use Revit structure. I also know some other companies are using, there's another BIM program that designed for rebars. So I forgot the name. So that's also another popular one. But a Revit structure, you guys learn that, we can definitely do the rebar design for that. It's after design development. Why? Because usually for schematic design, we don't have a lot of structural components, right? For MEP design, Bartley Cork uses Revit MEP. And for construction coordination, they use SketchUp plus Google Earth. This is more for the logistics planning and traffic control. Google Earth does have this API that allows, you import this SketchUp model into Google Earth. So it will generate a view of the finished building in the 3D model. So you can see how that is interweaving with the surrounding buildings and the potential traffic. Deep profiler. This is something related to like a cloud server to manage the information, and they use Navisworks for the coordination. This is pretty much clash detection, 4D simulation, and for MEP shop drawings, like I mentioned, shop drawings are for the fabrication. So it uses PractiCAD, HydroCAD, AutoCAD. So because the shop drawings programs, they are often use CAD. We have those machine that if you feed the design and the machine can, punch the holes in the right place and make the steel components automatically. Unfortunately, most of the machines are still based on CAD systems. So Battery Cork uses different CAD system for that. Kobe, I think I covered that one time. Kobe is the construction object building information exchange data. It's actually for facility management. It's a military product. So military have been struggled with maintaining and managing all the facility information. So they developed their own standard called Kobe. It's nothing but kind of like an Excel spreadsheet, and to tell you what information should be included in this Kobe document. Show you how it looks like. Yeah, this is how Kobe looks like. It's just you can imagine it's just a standard Excel spreadsheet with certain column for certain headers you should have, certain columns you should have. And nowadays, we do have the add-in in Revit, and the Navisworks can generate this Kobe file automatically from your design. And Bartley Cork also uses that. As you can see, Bartley Cork actually uses the BIM concept for all the phases. That's why they call this a VDC department, because it's not only just for the design, but also for construction. So virtual design and construction. This is another company that how they use BIM technique for different phases. Once again, from conceptual design phase all the way to facility management. I wouldn't cover the details now, but you can see BIM and cloud computing techniques are being widely used by different companies. The reality is, different companies have their own different practices. So this is something you guys have to learn. If you decide to get a career in building information modeling, you have to learn from the unique practices of these companies. All right. So with that side, I think that's pretty much what I want to cover for the BIM for pre-construction. Any question, any comments regarding the BIM for pre-con?
I do want to ask
Yeah.
for as builds because I saw there in the diagram that they use Revit. Is LiDAR or like what we saw last class scanning used for as built, or is it like drawing all over again with like the real measurements as it is constructed?
It depends. Yeah, it depends. That's a good question. It depends. Actually, I think LiDAR being more used for this product controls today. Like there are service companies that they scan your progress on a bi-weekly basis or monthly basis, and they have this program platform to overlay your scanned model with the actual design, original design, and they basically visualize the deviation you have from the point cloud model. And of course, the LiDAR can also help you build as build. This is more driven by the owner. And by the end, you do want to have a as build model. The best way to do it is to scan the building, get the point cloud model, and retrieve the model in Revit, so you have the as build model. But I have to say, for LiDAR, probably we are talking about 60% for project controls driven by the general contractor, 40% for as-built modeling driven by the owner.
Okay, thanks.
Yeah. Any other question, guys? No question? Yeah, you guys are so quiet. Okay, so actually our original plan is, I don't think we want to cover more knowledge, even though I have them ready to to show, but I think this is too much. It's long day. So my original plan for the face-to-face courses before the pandemic was we will have a day to fly the drone. But unfortunately, we just cannot do it, but maybe I can just show you quickly how the drone looks like at the end of today, okay? Just give me a second. Yeah, I know you guys are working on the photogrammetry and scanning project, and the old plan is to, loan this drone to you guys after I teach you how to use the drone, so you guys can basically make use of it. But anyway, let's see how it works. Just give you a quick view of the drone. So this is a DJI Mavic Pro drone. It's the Pro one with a better camera. And this camera is the, this is the, oh my God, what did I do? So when it starts, this camera will stabilize itself, a very smart system. This is the battery. The battery is actually pretty big in terms of the size. This is a 4,000 milliamp battery. But here's the interesting thing. This phone, my phone is also using 4,000 milliamp. This is a 4,000 milliamp. Why the size is so big? Can anybody tell me why? Okay, so I don't know the exact answer, but this is what I'm guessing. If the drone is for civil use, no matter the model, the brand, or how good it is, it can never fly longer than 30 minutes. The longest flight time is 29 minutes. No matter how they make stronger batteries, always 29 minutes. It's a regulation. So for civil use, the government just doesn't allow the drone to be flying longer than 30 minutes because these are very powerful toys that if you can fly the drone for such a long time, you could potentially do a lot of things that they don't allow you to do, right? So because of that, they limit the power joules of the drone. But technically speaking, you can still make a really good battery, and if you can hack it, you can still fly it longer. So I guess that's why they make this size of battery, but still not using the full capacity of the battery. Okay, and in order to for the portability, this design of the drone just has this folding wings. So what you need to do is just to unfold it. Like this. Okay, so now just unfold this drone. Now we have this 4 legs. And then the next step is to install the propellers of the drone. So keep in mind, when the drone flies, the motors are rotating in the opposite direction. So like, for example, this one is rotating counterclockwise, this one is rotating clockwise, and this one is counterclockwise, this is clockwise. Why is doing this? Because this is the way for it to generate this air circulation to move it up. So the drones, that's something you need to know. The 4 propellers are not rotating the same direction. They are rotating the opposite direction to create this uplift air circulation. Okay, so then that means you have to install the propeller to the right place. Why? Because we want it to, the design is when it rotates, it will fasten the propeller, not the opposite. Otherwise, if it rotates and this is become losing and losing, it will shoot out. So you have to recognize the color of this. So see, for example, I got 4 propellers. For this particular model, you have to see the color on that. Here's that. Shoot, I left the red propellers in my home. Anyway, so you see here, this one is silver, but the other side, there's no color, it's black. So you have to put the silver propeller to the silver motor and the black propeller to the black motor. Unfortunately, I got all silver here for some reason. Oh, here it is. I found it. Okay. So, and if you check the propeller, there's like a lock and unlock symbol. So basically you have to use the lock direction to fasten it. Let me just do it. And check, there's no silver color, so it goes to the black. You just feed it in, and when you hear the clip, so it's in. Okay, so once you have the propellers down, usually we add the battery later because it can be dangerous to use the drone. So we usually want to leave the battery installation later, and a lot of times we want to make sure the controller is started first. But let me just add the battery. I don't know how much. Yes, it should be fine. All right, this is how it looks like. I don't know if you can see this. Okay. And now, in order to fly the drone, you have to download this app. It's a DJI control app on your phone. Okay, so let me find it. Where's okay? So it's unloaded. I'm loading that again. Okay, while still working. Okay, the way for you to start your controller, so you got this safety mechanism. If sometimes you could just mistakenly push the power button. So the way for you to, where's that? Here, this is the power button. So you need to push it and hold it for like 3 seconds. And that's telling you that it's on. Okay. So it's the same thing for this drone. You push it, the power button is on top of that. You push it one time and push it and hold it for about 3 seconds, then it's on. But we will never start the drone before you have a full control to that. So now let me see if the app is done. Still loading. Still loading. You can use this drone controller to control drone without this phone, but I really want to use to see how stable the view is. So I would rather to have this app down. It shows connecting now. It's searching the signal from the drone, but since the drone is off, it just cannot discover that. I'm still waiting for the app to be done. Yeah, the speed here at a veil hall is just ridiculous. By the way, I know some of you have used the drone before, but like Ashish, you have a drone, right? Oh, you're not here. So anybody else have ever used the drone before? Nobody? Are you guys still there?
Yeah.
So, but you guys just have never used the drone, right? I guess that's why you guys are silent.
Yeah, doctor, I have a question.
Sure.
Does it have sensors so it doesn't hit like mountain or doesn't hit any?
I forgot to mention that. Yes, you know, this is actually a very expensive piece of toy because it got a lot of high tech. For this particular drone, it talks to 18 satellites to position itself. So it's ridiculously precise, accurate. And also you see this infrared lights here, the front, the bottom. That's okay. You guys can see probably here. You see the bottom, you got the infrared lights and the receiver infrared lights. The rear here, the side, that's camera, infrared camera. So it's pretty much like down, front, back, and the side got this avoidance, technology. So it would never fly into a wall. It's super safe, but it doesn't say that you can be totally reckless. I flew it for many years. I think one thing it still cannot handle is the trees. The infrared are not working perfect for trees, but other than that, like walls, like a building, if you control it to fly to a building, it will basically stop there and handle, hover there and let me know something's wrong. Okay.
Oh,
Yes,
great.
this is very safe. And the most important part of this, most expensive part in this toy is probably the computer chip. The chip can stabilize this piece of toy in ridiculous ways. I'm going to show you that quickly. So now I have my app open. I'm just going to open that. It's just use Bluetooth, agree. Okay, so now I'm going to connect it. Okay, now I have this app ready installed. Now it's time for me to start this drone. So I'm going to put it this way, clear my table a little bit. One time and push it, hold it for 3 seconds. And now it shows connected. All right, but I'm inside. I don't know how many satellites it can discover. But one thing I want to show you, see this camera, see how stable it is, right? So if I go into my device, why is showing disconnected? Ready to go, hold on. Oh, the cable is losing. All right, go fly. You guys can see this, the view. This is a real-time feed from the drone. All right. I don't know how to hold it all together, but I want to see this. You see, no matter how I move my drone, but the view is very stable. And it also shows the distance that sensed by this infrared camera. It tells me like how far away it is from, you know, the obstacle. This is the real-time feed of the drone. All right. So in order to fly this, you basically push the two handle, go inward, and hold it for like 2 seconds, 3 seconds. Then the drone will start.
Take off.
Yeah, it's the wind. It never moves. It doesn't move at all. When I push this handle, I want it to move forward. It just doesn't want to move. Okay, in order to stop that, you just keep pushing down, and give it a second, and hold it down, and now it stops. It's making a lot of noise. You know, it's beautiful outside, but inside is ugly. So anyway, it's over there, and you can probably hear. Let me see. One thing I can tell you is, you know, if you touch the motor now, it's very hot. And this system actually has this internal venting system that is blowing the air inside here to cool down the motors. As you fly, the more you fly, the hotter it will become. This is actually unfortunate another drawback of the drone. The motors can become really hot, but they do have this air. I don't know if you can hear that. So actually it's the air circulating inside the drone, try to cool down it. And here, just a quick view how we control drones. Come on here. You know, you have two handlers. You know, this part is moving forward, down, left and right. This is going up, going down, and turning counterclockwise, turning clockwise. And this drone is so smart. I got the additional functions on my phone. So for example, one thing is following function, active tracking. So if you go outside, I see you on the camera, I just touch you. So this one has this computer AI built in that it will basically recognize you, and no matter where you go, the drone will follow you automatically. And there's another function called tap fly. So once again, on the view, you just tap one area, and then the drone will recognize that destination and just go there. And also during the course to the destination, it will basically fly automatically to avoid any obstacle. And this one shows, I don't know if you can see the detail, shows the GPS of this drone. So anytime you feel it's unsafe, there's a lifesaver button. I call this lifesaver button, the home button, go to home button. You press it, the drone will come back to the departure point. You can also do it here. And also there's another app that is so popular. It's called Pixel 40. So for this one, you go inside, and if you open, let me just, oh, it's still loading. So if you open a map, and it's kind of like a Google map, and you basically define, a cover area, and this program will define the waypoints for the drone to fly and take pictures, and it's fully automated. And you just click the button and let the drone fly. The drone will take a lot of pictures, upload them to a server automatically, and run the photogrammetry automatically for you. So this is how good the drone is. And like I said, it's not just a toy. It got this computer chip, very powerful computer chip. Like even in a very windy situation, it can keep stable. So let me just play a quick video for you, and that's the end of today's class. Before that, let me turn it off. Always remember how to turn it off. Don't turn off. So when you turn it on, turn on the controller first, then turn on the drone. So when you turn off the system, turn off the drone first and turn off the controller. The principle is always have the control over a running system, okay? So how to turn it off? Push it one time, push it and hold it for 3 seconds. Now this is done. And then let's turn off the controller. Once again, push it one time, push it and hold it for 3 seconds. All right, so this is done.
Professor, what was the cost of this drone?
About $2,000.
How much, sorry?
2,000.
Oh, okay.
Yes. So let me find the video. And by the way, guys, I was having fun with this drone. I was doing this self-quarantine at home. I didn't know what to do, so I got this drone at home. I flew this over the neighborhood, and anyway, you guys know how fun it is. Let me show this video that I shot before. Okay, so let me share my screen. As you can tell, this is the picture from the drone. Hold on, I'm just rotating. I was rotating the drone. And as you can tell, it was pretty windy that day. But the camera view is so stable. You would think it's fixed on something, right? And just check the level of detail. By the way, this is Texas A&M. This is the admin building of A&M. That's the main roads going from Texas Avenue here, and that's the Bonfire Memorial. 4K video, 4K quality, pretty good. That's the entire view of Texas A&M. I think I have another video. Yeah, this is the video I took for the photogrammetry project we did, and this is the original 4K video. And that was not this Marvel Pro. That was a Fountain 4, as you can see. That was me, my students. And this building is Francis Hall, my previous department. And that's some academic building. This is main library. Let me fast forward. Make sure it is 4K. So you see the detail, right? The detail that drone can capture, and also how stable it is. That's why we could get the screenshots from this video and send like 120 pictures to that's us. Send 120 pictures to this Recap Pro and generate that high quality photogrammetry model. a challenge that using drone is it's always difficult for you to orient yourself, because when you after you rotate the drone, you don't know which is front, which is back, and when you fly to the left, you could fly to the upside. So you have to practice. I think that's a part you need to practice. Always use the lights. Drones have the red lights flashing in front and the green lights flashing in back. So you have to train yourself that from the camera view, from the lights flashing, to know which is the front. And see, at that time I didn't quite know how to fly the drone. You can see I turned my back to the drone, right? Because I'm trying to face the same direction of the drone. So it's easier for me to control the left and the right of the drone. But now I do not need to do that. Yeah, the one with the in the blue shirt, that was me. So I try to turn myself in the same direction. See the details. And the main thing is when drone flies to this head, you cannot hear anything from it. It's so quiet, and these guys just didn't. They were not aware of this drone at all. And when we build a model, we also build a 3D model of the facilities on the roof. This is the chemical engineering building. You never expect, just from this short video, you could recover the 3D model to that level.
Doctor, does it has a higher limit?
Yes, that's a good question. So for this one, the height limit is 500 feet, but it's on the software limit. There's a lot of ways on YouTube. So let me see. High altitude. There's so many ways, so many methods to break the height limit, and you can fly pretty high like this one. I think there's something that even higher than this one. This is 3,300 feet flying a drone, but it can be dangerous. I don't recommend you guys to do that. And talking about the coverage, I forgot to mention that the coverage is around the best you can do is 5 miles. This is you basically can fly a circle for 5 miles before the video signals cannot be sent back. So 5 miles, but this one is like say 4,000 feet. That's really big coverage. And the speed, the fastest speed, this one has different mode. For the sport mode, it will basically remove the constraint of speed. The speed can be around 30 miles per hour. No, not 30 miles. Let me see. I think it's faster than that. Let me check. DJI Mavic Pro. What is the speed? Yeah, it's actually 40 miles. 40 miles per hour. So actually, I flew it myself. I totally removed the speed constraints, and it's crazy. It's moving crazy. Okay, so like I said, guys, unfortunately, this year we just cannot do it together. But hopefully, at least you have a sense at how the drones look like, how stable it is. It's a serious business now, and hopefully in the future we can meet again, and if you have a chance to try it yourself. All right. So any question, any comments? If no, see you guys next week. And don't forget, next week you guys will be presenting the 4D and the photogrammetry scanning project. All right. See you guys later.